Fuel cells are often seen as an alternative to conventional batteries. Both use electricity, but there are a few key differences that you need to be aware of. So first, let's take a look at a conventional battery. A battery consists of one or more electrochemical cells, which store energy in the chemicals that they contain. When an external load, such as a motor or bulb, is connected to a battery, these chemicals react and release electrons, which creates an electrical current. The reactants in a conventional battery can be used up, in which case the chemical reaction will stop. But some batteries are rechargeable, if an electric current is supplied from outside to reverse the reaction that normally takes place. Eventually though, the chemicals in rechargeable batteries will degrade and hold less and less energy, and so will need to be disposed of. Often, the chemicals used in batteries are toxic and they can be harmful to the environment. So, what are the differences in a fuel cell? Well, fuel cells don't need to be recharged. They can be used constantly provided that the fuel keeps getting put in. The fuel that is normally used in fuel cells, hydrogen, can be a bit tricky to store, because it is a very light gas and so it needs to be pressurised to make it possible to store a lot of hydrogen in a small space. However, what makes hydrogen fuel cells so exciting is that their only product is water. And when the hydrogen is made renewably, there are no emissions whatsoever, making them great for the environment. Fuel cells generate electricity from the reaction between a fuel, which is normally hydrogen, and oxygen. Earlier, we showed how water can be separated into hydrogen and oxygen. Well, it turns out that hydrogen and oxygen actually quite like being together, so will get back together whenever they have the opportunity. More scientifically speaking, hydrogen gas and oxygen gas will react readily to form water, provided they are given some help to do so. This help can be provided by an external source of energy, such as a spark. And once they have started to react, they can do so very quickly and sometimes with explosive force. In a fuel cell, however, the hydrogen and oxygen molecules are kept separate from each other, so they cannot react explosively. They are separated by a special polymer membrane called an electrolyte, which does not allow oxygen or hydrogen molecules to pass through it. It does allow positively charged hydrogen ions known as protons to pass through though. These protons are produced by passing the hydrogen molecules over a platinum metal catalyst, which splits them into the protons and electrons. This splitting process is called oxidation. The electrons flow through the anode electrode into an electric circuit to power, for example, the motor of a car, and eventually end up on the oxygen side of the fuel cell. The protons pass through the membrane to the oxygen side, where they are able to react with the oxygen molecules and the electrons to produce water in a safe and controlled manner. Again, with the help of another platinum catalyst. This is at the cathode electrode. This is the overall reaction that takes place then in a hydrogen fuel cell. So the word equation would be hydrogen plus oxygen goes to water. Chemically, we could express this as H2 plus O2 goes to H2O. And remember that we need to balance this by putting a 2 in front of the H2 and a 2 in front of the H2O. So a fuel cell will use this process to produce an electrical energy, heat energy, and water. It is a very efficient way of converting the potential energy available, especially when compared to normal combustion engine cars. One potential use for hydrogen fuel cells is in cars. The major advantage of this compared to normal cars is having no polluting emissions. The hydrogen gas is, however, more difficult to store and transport compared to liquid petrol, although this can be an advantage. In an accident, the hydrogen would just escape into the air, unlike a conventional fuel, which can cause large vehicle fires. Currently, there are only a few hydrogen refueling stations across the country, and the developing process for making zero-carbon renewable hydrogen is in its infancy. This means that developing the infrastructure and the process for producing hydrogen is currently expensive. This is a disadvantage compared to battery electric cars, which can be charged at home, and normal cars, which have fuel stations everywhere. Hydrogen cars can, however, be refueled more quickly than battery electric cars, in around 5 minutes compared to several hours to recharge a battery car using standard chargers. Batteries hold very little energy compared to a hydrogen tank and a fuel cell system. If a car is to travel 300 miles, it needs 5 kilograms of hydrogen, 30 kilograms of petrol, or 700 kilograms of batteries. For larger vehicles and long ranges, it becomes impractical for the vehicle to carry the batteries it needs. For petrol cars and battery electric vehicles, the fuel is dependent on a country having access to or buying oil reserves or rare elements needed in batteries. Luckily for fuel cells though, hydrogen is widely available to all. Fuel cells have other uses too. They have a history of providing electricity in rockets and have the bonus of producing water for the astronauts. They have also been developed for uses in homes to produce heat and power, in buses and in trains, and in the future could potentially have many more technical applications to help our fight against climate change. So, by working together to reach the UN Sustainable Development Goals, through embracing innovative solutions such as fuel cells to tackle climate change, we can collectively make the world a better place.